So we're going to move on to section 5 where we're solving the rational expressions. And there's a lot of different ways of explaining how to do this. Um, and because I know some people would try to explain this by saying just, canceling out the denominators and make the problem a lot easier. And I'm not necessarily a huge fan of that, but that is an option, especially on a problem like this, where you can multiply both sides by the least common denominator, which would be 8. And the whole premise of that is then you can cancel out these 8s, and as you distribute this 8 in here, in case you didn't know, to multiply a whole number by a fraction, you multiply into the numerator and then divide by the denominator. So 8 times 5 is 40, divided by 4 would give you 10. Or you could do, 8 divided by 4 first and then times by 5. Either way, you get 10. Same thing, 8 times 3 is 24, divided by 2 would give you 12. And like I mentioned over here, the 8s would cancel, you'd be left with 7x. So probably what I would do is just subtract the 10x to the right side. So you'd have negative 12 is equal to negative 3x if my math is correct, and then divide by negative 3. Negative over negative is positive. 12 divided by 3 is 4. I would definitely encourage you to check your work too. The big reason why you need to check your work is because if you plug this number in and you happen to be dividing by 0 at some point, this answer would be wrong. But if you did that and you actually plugged in 4 in this case, well, the 4s would cancel there, so you'd be left with 5 minus 1.5, so it'd be about 3.5 on the left side. And same thing over here. Well, 4 divided by 8 would be 1/2, and 7 times 1/2 is 3.5. So this is correct as we move forward. So again, as you look at your least common denominator, in this case would be 5x. That's how some teachers will explain it. Just multiply both sides by 5x. Sometimes that's not really helpful as you do this problem, but the reason why this is how some people teach it is because the 5s will cancel, and on the right side you're just left with 2x. And on this side, as you distribute that 5x in there, well, the x's cancel. 5 times 6 is 30. And here, where you'll also have to be careful is the 5x's do cancel, but it's the quantity of x plus 9 that needs to be minus. So you would also want to distribute that minus in there. So really what you have is 30 minus 9, so 21 on the left side. And as you add x to the right side, 2x plus 1x is 3x. And divide both sides by 3 and you get x equals 7. And again, check your work. But I'll leave that to you to double check that that's right. And sometimes I explain this a little bit differently. Just kind of out of... I think I was supposed to use a graphing calculator to check your answer, right? Maybe I'll do that in the next one. So in a few problems, and maybe the way I want to teach it is more helpful if we had like inequalities, but right now we're just doing equations. So basically what it boils down to is I'm multiplying both sides by the denominator, the x plus 3. But if I do that, you can think of it this way as the left and the right side will cancel each other out. So the only way that this equation works is if the numerators are equal. So x minus 5 must equal, as you distribute that 2 in there, it'd be 2x minus 2. So I would subtract x to the right side, add 2 to the left side, and get x equals negative 3. Now here's the problem. If you were to take negative 3 and plug it back into the problem, what are we dividing by? Divide by 0. So we called this answer extraneous because algebraically it worked. I always misspell extraneous. You can Google how to spell extraneous. So in this problem, there's actually no solution. because when you check your work, we'd be divided by 0, and this is not correct. There is no solution. So I went ahead and typed in the left side of the equation in blue, and then the right side of the equation in red. And as you notice, these curves do not cross each other anywhere. And even if you zoomed in quite a bit and said, well, it looks like they're getting closer and closer, they never actually hit each other, because there's a vertical asymptote at the value where they would have equaled each other. So maybe while I'm at it, I might as well show you, that you can use a graphing calculator to see, so if I were to type in a 5x over 5x minus 1, just looking at the next one already, plus 1 over x, delete all this, and then the other one has 1 over 5x minus 1, and you zoom in to where it looks like the graphs cross each other, you can actually see an x value where they equals -1. I'm not sure if any place else hits the same value. So that's a tool that you can use as a point of intersection on a graph to see what the x value should be. Now, if I were doing this by hand without a calculator, I'd multiply both sides by 5x minus 1 and by x to cancel these out. That is your least common multiple here. So if you notice on the right side, the 5x minus 1 is a cancel, and you'd be left with x. And on the left side, as you distribute the 5x minus 1s in, and the x in, 5x minus 1 cancels, but you still have an x times 5x. So that's 5x squared. And then the next one, these pieces cancel, so you're left with 5x minus 1, subtract an x over. Let me scroll down a little bit. So let's see if we algebraically get the right answer. So let's see if that's factorable, 5x and x. Let's see, it'd have to be 1 and 1. If you FOILed, that would be a plus 5x minus 1x. So you do get x equals -1, but you also get this answer of x equals 1/5. But I didn't notice x equals 1/5 on my graph. Well, why not? Well, as we check for extraneous solutions, if I try to plug in 1/5 back into the equation up here, let's say if x is 1/5 right here, well, 5 times 1/5 is 1, minus 1 is 0, we'd be dividing by 0. So that's an extraneous solution. The only correct answer was x equals -1, which is why we check. We need to check our answers. So we have more problems along the same lines of getting the same denominator. So as I'm looking at this, like this denominator right here is definitely x plus 2, x minus 2. So I would multiply both sides of the equation by x plus 2, x minus 2. How about this? I'll just put, because I don't feel like rewriting it twice. So I'm going to multiply this term by all 3 of these. So on the leftist most fraction, that's not a real word, by the way, the x minus 2's will cancel, but I have 2 times the quantity of x plus 2. The x squared minus 4 simplifies to be x plus 2, x minus 2, so everything cancels there. Just make sure that you distribute that minus to everything. And on the right side, the x plus 2's cancel, x, and then x minus 2. So what we have on the left side, I'm going to do a lot of math all at once. The 2x, later we have a minus 2x, so those things will cancel. So we have 4 minus 5, which would be -1. And on the right side, we have x squared minus 2x. And let's add 1 over. So now over here is 0. And now this is definitely factorable. Factors of 1 that add to be -2 would be -1 and -1. So technically it factors to be x minus 1 squared, which means x equals 1. And as I go back to check my work, we don't have any domain issues. All of these x's could be 1. So we should be good. Should have the right answer. And you can check it using a graphing calculator. So moving on to example 6, I'd probably be doing a lot of the same stuff, except there's not a good factored out form in any of these. So this looks really messy to me. Now let's just kind of jump right into it. If this thing is factorable, it'd be 2z and z. Let's see, does 3 and 2 work? I think so. 2 and 3 multiplied would be 6. 2 times 2 would be negative 4z plus 3z. Oh man, the least common multiple here is pretty ugly still. Well, let me just show you another way I would do the problem. Is the least common multiple throughout the entire problem would be a 3az, a 2z plus 3, and a z minus 2. And then on this side, I would also want to multiply by 3, a z, a 2z plus 3, and a z minus 2. And what I can do now is I can look at the denominators and see what's missing. So this 2z plus 3 is accounted for. The z minus 2 is accounted for. I'm missing a 3 and a z. So I'm going to multiply the top by 3 and a z. So that's 3z squared. This is a lot of things missing. I guess what's sort of nice about this is the only thing it's missing is this 2z plus 3 and z minus 2, which we factored out earlier as this. So notice the minus I'm also going to distribute to all of those. 2z squared plus z plus 6. Now if you look on the right side, we have a z and we have a z minus 2. What we're missing is the 3 and the 2z plus 3 that we would also have to multiply into the top. So this would be 6 that I need to distribute to each term. So it'd be 6 times 2 is 12z, and then 6 times 3 would be 18. And the reason why I sometimes teach it this way is so students see that if the denominators are the same, that means the numerators must be the same as well. So if I switch back to my other color, and you imagine that you're multiplying both sides by the same denominator, is really what's happening. And then I would rewrite this piece as 1z squared. And I have 1z, then I'm going to subtract 12z over 2, so that's negative 11z. And 6 subtract the 18 over would be negative 12 is equal to 0. So now I can solve this. It would just be negative 12 plus 1 as your factors. So your answer is going to be z equals 12 or negative 1. And as you check for extraneous solutions, both of those answers work. So we should be good. So at any point, if you feel like pausing and re-watching and re-working through the problem on your own, by all means go for it. And I barely squeezed in before the end of the lesson that this is your assignment coming up.